Welcome to everyone. In this presentation, we have go for just basic knowledge of submarine optical fiber cable. What we cover about this in this presentation regarding a brief history, how to submarine cable work, installing a submarine cable, submarine cables and related environment and its future, and finally in the short this presentation what we go for conclusion. Let's start now. A brief history. Submarine communication cable play a vital role in the global communication network, and any disruption or damage to this cable can cause significant disruptions to internet and telephone service. The history of submarine communication cable date back to the mid 19th century when the first successful transatlantic cable was laid between Ireland and Newfoundland in 1858. This cable enabled telegraph messages to be transmitted between Europe and North America for the first time, greatly improving international communication. The first international fiber optic cable was the TAT-8, which was laid in 1988 and connected the United States with France and the United Kingdom. TAT-8 was the first submarine cable to use fiber optic technology, which allow for much faster data transmission speed than previous copper-based cable. TAT-8 was a major milestone in the history of global communication as it allowed for faster and more reliable transmission of data between North America to Europe. The cable was able to carry up to 40,000 simultaneously telephone calls as well as data transmission need up to the 280 megabit per second. That it was a joint project between several telecommunication companies, including AT&T, French Telecom, and British Telecom. The cable was laid across the Atlantic Ocean using a specially designed ship, and it was the first of the many fiber optic submarine cable that have since been laid around the world. Today, fiber optic submarine cables are the backbone of the global communication network, carrying vast amount of data between continents and enabling fast and reliable internet connectivity for the people and business around the world. Now here a comparison between the old submarine cable and the current and new marine cable. Now this is the submarine cable during on your screen. This is the telegraph era. The main content of this Cable is a conductor. This is usually copper for the insulation of this conductor. Help of the gatta percha regime, special types of mechanism for the insulation purpose and give the more strength and more protection. The cushion line, this is also jute yarn, and this is the main, after this main part, it required inner protection, and this wire is a wire armor, some is hard material, and again wrap help of the jute of this contain wire and the uh, many layer depending on the cable length and more outermost protection again wire arm, and finally the jute wrap, it is also contain armor. So here is the just diagram. This is the taken from the museum, and same after the finally Atlantic cable one available in the museum. This look like this. This diagram is the year of 1866. Now we go for the modern era submarine cable. So basically this is the in the current type submarine cable use of the optical fiber, and optical fiber likes on ground and everywhere it is the silica glass, and for the core strength and separation help of the polythene and fiberglass edge, and then try to required jacket polythene line, and finally one more copper conductor in upper of jacket, and again protection of the this copper help of the polythene jacket and required protective armor. Uh, this is the steel wire and outermost protections and wire content is also again this is the polypropylene arm. So these all layer required construction varies with the manufacturing and seabed condition. Cables may have no armor in the stable deep oxygen site or one or more armor layer for the energetic zones, for example, coastal seas in life. So there are a lot of changes in earlier uh, submarine cable and current cable. Earlier main focus is the copper based wire, and the current is the totally now in optical fiber. So now we discuss how to submarine cable work. Submarine communication cable work by transmitting telecommunication signal through fiber optic cable that are laid on the seabed. Here a brief overview of how submarine cable work. First, transmission of signal. Signals are transmitted from a land-based station to a submarine cable station, where they are converted into optical signal and transmitted through the fiber optic cable. The signal are carried by light wave that travel through the fiber optic cable at very high speed. Then amplification of the signal. As the signal travel through the submarine cable, they can experience some losses of the strength. To compensate for this loss, submarine cable system use a series of amplifier spaced at a regular interval along the cable that boost the strength of the signal. Then regeneration of the cable. In addition to amplifier, submarine cable also use regenerator which decode and regenerate the optical signal to ensure that they maintain their integrity and clarity as they travel through the cable. Transmission to the receiving end. Once the signal reaches the far end of the submarine cable, they are converted back into electrical signal and transmitted to a land-based station, which they are then routed to their final destination, such as a computer, phone, or other devices. Here we can see typically submarine cable system. This is a network management. I just take here a diagram. Help of the source is available. UK Cable Protection Committee, Alcatel Lucent Submarine Network. So in this presentation, you can see here on ground cable landing station. Here is the terminal equipment and cable after laying. This is the path and different. This is the arm type cable like optical fiber in old time the copper base, and this is the traveling of the signal lightweight in the deep of the cable, and some location this is the use of the repeater. So submarine cable are designed to very reliable and durable with multiple layer of protective materials to withstand the harsh ocean condition and prevent damage from fishing equipment and both anchor. These cables play a vital role in the global communication network, carrying vast amount of data and enabling fast and reliable internet connectivity for people and business around the world. Now discuss about size of the submarine cable. The size of deep ocean fiber optic cable can vary depending on a number of factors, including the number of fiber pair within the cable, the types of protective layer used, and the distance over which the cable must be laid. Here are some general specification for typical deep ocean fiber optic cable. The most important parameter is the diameter. The diameter of a deep ocean fiber optic cable can range from around 16 mm to 100 mm, depending on the number of fiber pairs within the cable and the protective layer base. The outermost layer of the cable is typically made of steel wire or a similar material to provide protection against damage from the fishing equipment and the other potential hazard. Next parameter is the length of the cable. The length of a deep oxygen fiber optic cable can vary depending on the distance over which it must be laid. Some cables are only a few kilometers long, while other can be thousands of the kilometer long. For example, that 14 cable which connect the United States with Europe is approximately 15,428 kilometers long. Repeater spacing to maintain the strength and clarity of the signal as it travels through the cable. Repeater are used to boost the signal at regular interval. The spacing between repeater can vary depending on the specific cable and its design, but it is typically in the range of 50 to 100 kilometers. Fiber pair count. The number of fiber pair within a deep oxygen fiber optic cable can also vary depending on the specific cable and its intended use. Many modern cables have 4, 8, 12 or more fiber pair, which allow for multiple channels of data transmission over a single cable. Overall, deep oxygen fiber optic cable are highly engineered and designed to withstand the harsh conditions of the oxygen while providing reliable and high speed data transmission over long distance. Here some example for more try to understand. Cable are a small deep soaking type with a without protective arm are typically 17 to 20 diameter, size of golden horse or beer bottle cap like. Armor fiber optic may reach 50 nanometer diameter. In contrast, submarine oil gas pipeline can reach 900 diameter, and fishing travels typically range over 5,000 to 50,000 wide. One of the longest cable system in the Southeast Asia, Middle East Asia, Europe, West Europe, three system SCME WE3 with a total installed length including branch almost 40,000 kilometer. So this is just a deep sea cable in the black, sanctioned to show internal construction, fine strand at the top, optical fiber used to transmit data. So 600 around oil gas pipeline. So this is a modern fiber optic cable in hand, scale relatively to 600 diameter subsea pipe. Okay. So now here, joint box and repeater in the submarine optical fiber cable like this. So modern optical fiber joint box and repeater roughly to the scale here now. So this is approximately 6 inch, and here just more in detail you can see approximately 10 meter. So here band limiter buffer, flexible cable, amplifier section between this jointer and flexible cables. This is general structure in the submarine joint closure box, you can say. And this uh, third is like big, approximately 14.5 inch long. This is the and similar manner explanation of the same as the middle. This is a 10 diameter jointer box. Now, how to install a submarine cable? Installing a submarine optical fiber cable is a complex and challenging process that required specialized equipment, skilled person, and careful planning. Here are the general steps involved in installing a submarine web cable. Cable route survey, the most important part of any either go for on ground, yeah, go for any sea. Before laying the cable, a detailed survey of the oxygen floor is conducted to identify the best route for the cable and assess any potential hazard or obstacles that may need to be avoided. This survey typically involves the use of specialized sonar equipment and underwater cameras. Cable manufacturer. Once the cable route has been determined, the cable is manufactured to the required length and specification, including the number of fiber pairs, the outer protective layer, and the spacing of repeater. The next is the cable laying. The cable is loaded onto a specialized cable laying ship, which then travel along the planned route, laying the cable onto the oxygen floor. The ship uses a series of equipment, including a plow and a remotely operated vehicle, to worry the cable under the seabed to the protect it from the damage. Next, repeater deployment. At regular interval along the cable route, repeater are the deployed to amplify the signal and regenerate the optical signal. The repeaters are typically lowered on the seabed using a specialized cable laying vehicle and connect to the cable using a specially designed connector. Termination, cable termination. Once the cable has been laid along the entire route, it is terminated at the boat end to connect it to the land-based communication network. This involves connecting the cable to the landing station where it is spliced into the terrestrial network and connected to the transmission equipment. And now finally testing and commissioning. After the cable has been installed, it undergoes a series of tests to ensure that it is functioning correctly and that the signal quality is within acceptable limit. Once the cable has passed this test, it is commissioned and put into the operation. Overall, installing a submarine optical fiber cable is a complex and demanding process that required careful planning and execution to ensure that the cable is laid safely and reliably. So this is the just cable route survey carefully and selected to minimize environment impact and maximize the cable protection. Just here one diagram and some roadmap for the help of presentation. What we can say, seabed mapping system accurate depth, topology, slope, angle, and seabed type. So this is just example and guided by the route survey, specialized design ships are used, accuratable place cables are on beneath the seabed. So shallow water laying may be the added by divers and deep water laying may be involved remotely operate vehicle. So here now a small video. This video especially help of the most popular submarine cables in the field of the optical fiber, in the field of the gas oil pipeline and power cable. So this video may be helpful to all of you to easily understand how to survey cable laying, just basic idea and this company presentation. So you can see here.
Subsea cables are vital to two major sectors of the global economy, telecommunications and energy, which includes interconnecting grids, oil and gas, and renewables. This video will discuss the state-of-the-art in submarine cable laying, including the main problems and cutting-edge tools being used by cable installers. First, let's see who is laying submarine cables and why. The telecom industry was the first to lay submarine cables in the 1850s. These cables are the backbone supporting the explosion of the internet, and 99% of the world's international telecommunication travels through them. The subsea power cable industry is currently experiencing rapid growth, spurred on by two main factors: the emergence of offshore renewable energy, especially offshore wind, and the increasing demand for grid interconnection between networks with excess electrical supply to others with excess demand. With energy prices rising, seismic oil exploration is being pushed into deeper offshore fields, requiring the ocean bottom cables to be laid and retrieved very accurately in even deeper waters. Cable laying techniques before the 1990s were still relatively crude, leading to cable failures. The basic issue was this: cable installers didn't have a good picture of what the cable was doing below the surface. Then, in the late 1980s, Mackay Ocean Engineering presented a solution. With modern computers, Mackay developed a rigorous 3D model of the cable, called Mackay Lay, that accurately computed and displayed the cable shape and touchdown conditions in real time. The Mackay Lay model can take into account the cable properties, all forces on the cable, the seabed contours, the ship maneuvers, and even ocean current readings from a current profiler in real time during the lay. Operators use Mackay Lay software to monitor and control the cable's position and bottom tension, allowing them to optimize the vessel navigation and cable payout instructions for a safe and swift cable lay. These two variables, position and tension, are of the utmost importance for a cable lay. Mackay Lay provides control over the cable's position and tension at any depth. Here's how. During a lay, Mackay Lay gives the vessel and cable engine instructions to keep the cable right on track, and it retains a log of the as-laid path. For power cable lays, Mackay Lay can place the cable on the seabed with high accuracy and can minimize or eliminate the need for expensive ROV touchdown monitoring. In addition, Mackay Lay can precisely control the retrieval of cables to minimize lateral dragging and damage. Retrieval speeds with Mackay Lay can be easily doubled, minimizing ship time and repair costs. Installing any type of cable with high slack can result in using more cable than is necessary and increase the chance of unwanted loops. Also, laying a power cable with low tension or slack could result in a damaging kink at the touchdown. On the other hand, installing a cable with tension that is too high will result in suspensions leading to extreme forces at the contact points. This exposes the cable to higher current forces, which vibrate the cable, causing wear and in some cases failure at the heavily loaded contact points. Mackay Lay provides tension control for power cable and flexible pipe installations where a residual tension at the seabed is needed. A feature called auto tension automatically adjusts cable payout and vessel navigation to keep tension within acceptable limits, paying out cable faster when it is too high and vice versa when it is too low. In 1989, Mackay Lay was first used to install a power cable through a treacherous and narrow corridor in deep waters. This remains the highest precision deepwater power cable lay in the world to this day. Since then, Mackay Lay has become the #1 subsea cable installation package in the world, used by over 75% of the world's subsea cable ships. And although Mackay Lay is for use on a vessel at sea for real-time installation and repair, Mackay has developed other very popular tools for route engineering, simulation, and training.
Okay, so this is just a basic idea ki, what about cable laying and survey and such type. So now cable burnal. Cable may be buried in a narrow, less than 1 meter wide trench, cut the water jet or plow. The plow lifts a wedge of sediment so that the cable can be inserted below. Burial speed depend on the cable types and seabed condition. For an armored cable, the burial speed is about zero point 0.2 kilometer per hour. So this is just overview like this. So cable are typically buried 1 meter and exceptionally up to the 10 meter. Beneath seabed to the protect against travel fishing, ships, anchoring, and other activities. Vernal may extended from the shore of the about 200 meter water depth, which is the present limit of the travel fisher. Varial may locally disrupt the seabed along the narrow path and form turbid water. The extent of this is dependent upon burial technique, seabed type, wave, and current actions. In the absence of the cable-based studies, analysis of the seabed disturbance from fishing and other activities suggest that impact are short life around month where wave currents are active, but possible longer life in deeper, less turbulent water. In the event of the fault, cable has the required civet, so replacement the section can slide it. Now we discuss submarine cable and related environment. The environment can have a significant impact on submarine optical fiber cable. Here some environment factor that can affect submarine optical fiber cable. The most important, water pressure. Submarine OF cables are typically installed at the depth of the several thousand meters, where the water pressure can be many times greater than at the surface. The pressure can put stress on the cable and its protective layer, potentially causing damage or degradation over time. Oxygen currents. Oxygen currents can cause the cable to move or shift over time, potentially damaging the protective layers or causing the cable to break. Current can also bring debris or other object into contact with the cable, which can cause damage or abrasion. Temperature. The temperature of the oxygen can also affect submarine optical cable. A change in the temperature can cause the cable to expand or contract, potentially leading to damage or stress on the cable. Marine life, such as fish and other animals, can be attracted to the cable or become entangled in it, potentially causing damage or disruption to the signal. Human activities. Human activities such as fishing or shipping can also pose a threat to submarine optical fiber cable. Fishing net or other equipment can become entangled in the cable, while ships and other vessels can accidentally anchor on top of the cable, potentially causing damage. The future of submarine optical fiber cable look promise as the demand of high speed, reliable and secure global connectivity continue to grow. Here are some of the key trends and development that are shaping the future of submarine OF cable. Increased capacity as the demand For the data continue to grow, there is a need for the submarine wave cable that can support higher bandwidth and transmission speed. Advance in technology, such as the use of higher capacity fiber pairs and more advanced modulation scheme, are helping to increase the capacity of submarine wave cable. Greater resilience. With the increasing importance of global connectivity, there is a need for submarine optical fiber cable that are more resilient to disruption such as natural disaster, cyber attacks, and human error. Newer cables are being designed with redundancy and diversification in mind to ensure that disruptions in one part of the network do not affect the entire network. Improve security as cyber threats become more sophisticated and frequent. There is a growing need for submarine web cable that are more secure and resilient to the cyber attack. Newer cable are designed with advanced encryption and security feature to protect against data breaches and other threats. Expansion in the new market as more region and countries seek to improve their global connectivity. There is a growing demand for the submarine web cable in new and emerging market. This includes regions such as Africa, Latin America, and Southeast Asia, which are seeing increased investment in the submarine web cable infrastructure. Advanced in the installation and maintenance. The installation and maintenance of the submarine optical cable is a complex and challenging process, but advance in technology and technique are helping to make it easier and more efficient. For example, new ships and equipment are being developed to make cable laying and maintenance faster, safer, and more cost effective. Overall, the future of the submarine optical fiber cable look bright as they continue to play a vital role in the connecting people and business around the world. Now, for conclusion, for this smart and short presentation, in conclusion, the use of the submarine optical fiber cable has revolutionized the wave data is transmitted globally. The vast network of submarine web cable allow for high-speed, reliable, and secure transmission of the data across the world ocean. With the increasing demand for data and the need for global connectivity, submarine web cable are set to play an even more critical role in future. The use of submarine web cable has opened up a world of opportunities for business and individual alike, enabling them to communicate and collaborate across the vast distance. The technology has facilitated global trade, education, research, and innovation, bringing people closer together than ever before. Despite the challenge posed by the environment and the complexity of the installation and maintenance, the development of newer, more resilient, and higher capacity submarine optical fiber cable is helping to ensure that data transmission remain fast, secure, and reliable with the continued growth of digital economy and the need for global connectivity, the future of the submarine optical fiber cable look bright, and they will continue to be an essential component of the world communication infrastructure. In the last, I just share so one video. In this video, from the history to 2023 till time, how to submarine cable in the whole world develop point to point. So then we can close the session. Thank you everyone. And